Thank you, everybody, again for being here with us. Now it's the time for Cara Serenius to give her talk. The title of her talk is Mining Case Studies, Decarbonizing Rio Tinto Operations, the 32 Kiloton CO2 Challenge. So, Cara, the room is yours. So please go ahead.
Hi, thank you for inviting me today. I will just share my screen. There we go. So Rio Tinto, we're one of the largest companies for mining in the world. We operate in several different countries, and we've made a commitment to be net zero by 2050. And as much as 2050 seems like a long ways away, it's right around the corner, and we have a lot of big challenges that don't have very clear and easy solutions to get to zero emission technology. And so we're doing a lot of work to work with new and emerging technologies as we do the transition to a net zero operation. So my job is with the Center of Excellence. So it's a global department where we work on energy and climate change. So we work with all of the different groups. So we're split into groups of copper, aluminum, minerals, and iron ore. And so we provide services across the groups. So my job is the long-term strategic plan, and I work with the specific sites while we make plans of how to transition to a net zero operation. This is a photo of our Pilbara, which is in Australia. That's the iron ore mines, and that's an iron ore train, which is one of our challenges of getting net zero locomotives. So we see ourselves as a really important part of the transition to net zero for the globe. We provide materials that are essential to the low carbon economy and will be critical going forward. This includes battery materials, general materials for building things such as wind farms, solar, batteries. That includes copper, which is really important for any sort of electrical infrastructure, aluminum, which is coming to the forefront because it's so light and strong, so it's important for vehicles and other applications. Iron ore is used in steel, really is the fundamental building block of industry and infrastructure. So that's everything from the rails themselves to wind turbines to any sort of infrastructure, bridges. Borates, this is one of our products that's very important as small quantities in many things, including building materials and fertilizers. Titanium dioxide is one of our main minerals products. It's used in many products, retail as well as industrial. And lithium, which of course everyone knows about for rechargeable batteries. It's becoming a very critical mineral with limited supply. So these are all minerals that we currently have mines for and processing facilities, and we're expanding our capacity as well. So our strategy is, of course, that as I just talked about, we are producing materials for the low carbon future. We plan to reduce our carbon footprint. By 2050, we have a commitment to net zero. And we are partnering with our downstream and upstream value chains. So what that means is we're partnering with our incoming materials to make sure they can transition to net zero, as well as our customers. And that's a really big part of our picture because we produce iron ore, which generates steel. And there's a lot of carbon emissions in the steel making process. So as in my title, we're 32 kiloton challenge. But if we look at our scope 3, which is our entire carbon footprint, including our customers, we're at about 600 kilotons. And so partnering with our customers is a really big part of our transition. And lastly is enhancing our resilience to physical climate risks. That touches a bit on Carlos's talk today about tailings dams, but there's also all of our other parts of our operation and being able to adjust and assess our risks and make changes in our operations to ensure that we're safe for the communities, we can continue our operations without interruptions, continue production, and not have any environmental impacts as well. So there's a significant change with climate change on our risk strategy. So here's a bit about our commitments. We've said we will reduce 15% of our scope 1 and 2 by 2025 and net zero by 2050 or sooner. We also made a commitment to 50% reduction by 2030. We've also committed to carbon neutral growth. So that means if we bring on a new mine, for example, Rincon in Argentina is a new mine for us, we will do that in a carbon neutral way, which means if we bring on new emissions, we will offset and use less emissions at another facility. And that's a really big commitment for us. Scope 3 is, as I discussed, about our partners. So that's working with our value chains to determine how we can best work with them to reduce our Scope 3 emissions. And we've committed to spend $7.5 billion in the next 8 years. That's a really large number. And we think we have a lot of projects that are competing for that amount of money. It looks like a really big number, but for Rio Tinto, it's a small portion of our overall budget. But that's 7.5 billion that's going to be spent directly on capital expenditures to reduce carbon emissions. So we emit 31.5. So this is 2020 data. So it's not our most current data. I used an old slide set, but I think it's relevant in any case. Our emissions come from electricity production, which is 14.2 million megatons, and 6.5 megatons come from anodes and reductants. And what that means are direct emissions from our processes. For example, aluminum is our main emission there. And when you make aluminum, you take a carbon block and you react that, and that's what's with the alumina, and that makes aluminum. And so we have direct emissions off of those processes, which makes it a very difficult solution in order to abate those emissions. When I say abate, I mean reduce the emissions. So that's a very big challenge for us. There's 5.7 megatons from mobile diesel. So this is our haul trucks, is the majority of our mobile diesel, as well as the locomotives. And we have 4 megatons from process heat. That's namely from steam, but also some direct heat in furnaces. And the last one is process gases. And that's very specific from, for example, in some mines, our tailings have emissions directly, CO2, and so those are also very difficult to mitigate. So we want to be part of the energy supply chain for a net zero world. We want to look at this at a global scale. We want to be part of the solution. As engineers, I think we all want to be part of the solution as well. So it's good to be working for a company that sees themselves as part of the global solution. That includes renewable energy sources for our electricity, non-electric energy conversion. So that's looking at hydrogen options for our operations. Net zero pathways is the work I'm doing for long-term strategic planning. We have energy storage that we're looking at both in terms of batteries as well as thermal storage. Green technology retrofits, that includes battery electric vehicles, any other technology. So we call those more replacement capital projects. And then net zero products. And what net zero products or carbon neutral products is another term that is used. And that's being able to sell, for example, copper as a net zero copper product. And that encourages our customers to purchase our products other than other companies because we can say that we have a net zero or a carbon neutral product. So getting into some of the details of our projects. For our electricity, some of it is scope 1, which is direct emissions from electricity we produce, or scope 2, where we purchase electricity. Either way, the solutions are very similar. So you can see that is a solar farm that we have installed in Northern Australia. Our emissions come from 53% aluminum assets in Australia. They rely on coal currently for their electricity production, and so we're working to stop using the coal electricity. 39% of our emissions come from our copper. KUC is Kennecott copper in the United States. OT is in Mongolia. RTFT is in Canada, which is an iron ore asset. RBM is our South African asset, and QMM is in Madagascar. So we have a range of grids that we're working with, electricity grids, and they all have their own carbon emission factor, and working with the utilities as well as private partners to develop wind, or for example, solar farms, or to work with the utility themselves to reduce their overall footprint. 8% also comes from the Pilbara, which is we generate directly and use that electricity. Another focus is intermittency. When we start relying on renewables, we need to consider intermittency, and that means investing in long-term energy storage, batteries. How do we integrate our renewables into our facilities, which are often remote grids? And there's a lot of challenges with bringing solar or wind from where it's generated to where we use it. And the scale of what we're doing is really, really large. So for example, it's not this size. Well, this is a small solar farm, but it would be 100 times this size in order to electrify some of our assets in Australia. So the scale of our electricity challenges is very large. Our reductants, this is our aluminum assets, is 78% of our reductants. The picture on the left is of Alesis, which is our research and development joint venture that we're doing with Alcoa to develop an aluminum anode that doesn't release carbon dioxide. That's currently still in development, but it's very important for our green future to be able to reduce our emissions from direct reductants. We also have some reductants in our iron ore, which is our TFT process, and RBM as well, which is a titanium dioxide product. IOC is one of our critical assets in Canada, which is an iron ore asset. It is a small amount of our reductants, but is one of our best assets in terms of iron ore, as it is a processing facility that is powered by hydroelectric. And so we're looking at bringing that iron ore product or steel product to market at a very low carbon compared to other steels, and trying to get that to net zero, to be a net zero steel product. So as I mentioned, it's a novel process. Alesis is one of our flagships, and it will revolutionize the way that we make aluminum. Alternately, we're looking at carbon capture for some of our facilities in Iceland, for example, and other places we make aluminum, in order to continue to make aluminum and then capture that carbon and store it underground. We are using carbon mineralization there. And benefaction is upstream or processing. So we're trying to do more of the processing on site in order to reduce the transport costs. So process heat, 88% is for our Yarwun facility, which is a refinery, as well as the Vaudreuil refinery. So those are refineries of alumina, and they use significant amounts of process heat in order to transform the bauxite into alumina. So one of the things we're doing is looking at steam raising, and we're looking at combustion fuels, and that's namely around hydrogen, whether that's an option for retrofit in our refinery facilities. One of the challenges is definitely operability. Hydrogen is not a new technology, but managing it on our sites is new for us. Our mobile fleet is, when you talk about mining, you often think it's our majority source, but it's about 13% of our total. That includes the loading and drilling and support units, the haul trucks themselves, and the rail. You can see the breakdown there. The challenges are around battery operation. It's in order to haul the amount of material we're looking at, the batteries that are required are very large. If you want to be able to run, say, for a whole shift, you need a very large battery. At the moment, the technology doesn't exist, so we're working with our partners in a initiative called Charge On Innovation. So it's working with various manufacturers of haul trucks, Komatsu, CAT, at developing a haul truck technology, battery electric technology. And we've got the first prototypes rolling out already. An alternate option is fuel cell application. We don't have any on our sites yet, and they're developing some technology there as well. The challenge is the system efficiency. When you generate hydrogen, you lose a lot of efficiency through the conversion to hydrogen and then back to electricity. And then system integration is always a difficult challenge at our operations, especially with remote operations. Whether you go with electricity or hydrogen, there's a challenge to deliver the energy to the haul trucks. And that's all I have.
So thank you very much, Cara, for your very interesting talk. So we have some minutes for questions. So mic is open for everybody to ask the questions that you would like. Don't be shy. So Sebastian, yeah, please go ahead.
Cara, thinking in green hydrogen to replace conventional fuels, Rio Tinto is thinking in if this type of technology involves some risk, because there are some information in which they say that if there are hydrogen delivered to the atmosphere, it's possible to produce different environmental problems. Is thinking Rio Tinto in that type of problems, or in what manner is possible to reduce any risk of green hydrogen?
So the risks around hydrogen are known. There's a safety risk, definitely. The environmental risk is lower. We're more concerned around the safety risk, operability risk on site. There's, when you generate hydrogen, you need to store it. It is a much smaller molecule than natural gas. And so even our pipeline infrastructure needs to be reviewed to understand if it's tight enough. So leaks become more of a problem with hydrogen because the molecules are smaller. So the same pipeline that may not be leaky with methane may be leaky with hydrogen. So that's a really big risk that we can see for operability. And the explosion limit is much lower. So you don't need as much hydrogen leaking when it becomes an explosion risk. And so the overall safety program that needs to go around hydrogen implementation is much larger, much more precise, and the risk is very high for explosion. When we talk about hydrogen, we only talk about green hydrogen. So we don't want to be using hydrogen from coal or from natural gas. We would only invest in hydrogen if we were to also invest in the green infrastructure portion. And so a solar farm, a wind farm, and using hydrogen as that battery storage. And so instead of using batteries, so you would need to, if you have a solar plant, you need a battery that's big enough to deliver energy when there's no sun. We would then convert into hydrogen and use hydrogen as a battery. The benefits of hydrogen are specifically interesting for us around the process heat, where we need really high temperatures to do some of our processes, especially for alumina refineries. We need very high temperatures in order to crack the bauxite. We call it calcination. And so to go through the calcination process, the Bayer process, you need very high temperatures. And there's not a lot of technologies out there that can provide that temperature. And that's why we look at, and these are very large kilns as well. And so hydrogen is a direct replacement. We're doing trials, or going to be starting trials to see if it's a direct replacement in calcination. And if that's successful, then we will be looking at whether we can invest in hydrogen at all of our refineries. Did that answer your question, Sebastian?
Yes, thank you. Yes, I understand that it's very clear.
Have some more time for questions. Haroldo, please go ahead.
Yeah. Well, thank you very much for your talk, Cara. I'm very glad to hear that the big mining companies are interested in reducing the carbon footprint. You talk about 7 millions to lower billions, 7.5 billions to lower emissions through funding. So how we can to apply to some of fundings, or what are the special topics that Rio Tinto is willing to fund? I would like to know a little bit more about that, please.
So that 7 billion is inclusive of all of our initiatives internally. So everything from our research and development in thermal energy storage and ELYSIS, all the way through to investing in solar farms at some of our more remote applications. And so we've committed to spend that much in the next 8 years, and we'll be spending more in the next by 2050. But I think the intent of that announcement is really to show that we're committed to spending our funds, and we're committed to prioritizing decarbonization. So it's not a chunk of funding that we can apply for, but it's to allow all of our operations to invest and decide which initiatives are most important for them to reach net zero. And so they understand that there's a commitment from Rio Tinto, and that they can put their projects forward, the ones they want to proceed with. So if for example, Rincon in Argentina has some research they want to do on filtered tailings, that could be funded by that 7.5 billion. So the sites basically decide what initiatives are right for them, and then they go through our processes, and there's money earmarked in order to support all of that process internally.
Okay, yeah, but that's my question. So there are some initiatives that are taken care of. So how can we know what we can help to solve these issues?
As a university, or
yeah.
So I think one of
or investigators or researchers that are interested in giving a hand to help those issues.
So we have partnerships with universities across the globe, and typically we set up relationships if there's a specific researcher that has an idea that coincides with the initiatives that we're progressing. So if there's a specific research topic that Temuco is strong in, then we can develop a relationship on a specific topic. Or if there is a site that has a connection as well to the university, they can propose that we do work with that specific university. So we have a whole partnerships program with universities that we could look into if Temuco is interested in working with Rio Tinto.
Okay, thank you very much.
We have time for one more question from the audience, in case you have one. Apparently not. So apparently we don't have any more questions. So we would like to thank you again, Cara, for being here, for joining us in this at this time of the year, which is, pretty close to holidays, so everybody's a little bit busy before that. So we are very glad to have you here. I will also would like to thank Carlos Cachutolo for the talk at the beginning, and of course, we would like to thank everybody that is here present, watching the different talks. So thank you very much, Cara again, Carlos again, and everybody. I wish you a very nice day and a very nice holidays, in case we don't see each other again until the next year. So thank you very much.
Thank you. Bye bye.